Finding the indicated term of a sequence with a given general term. Another lesson for Math 10. A sequence or progression is a list of numbers written in specific order that follows a definite pattern or rule. Each number in the sequence is called term. The first number is called the first term, followed by the second term, and so on. Subscripts are used to designate the ordinal of a term. It is common to use a sub 1 or the first term, a sub 2 or the second term, a sub 3 or the third term, and so on up to the nth term to designate a sequence of n terms. Examples. If we are given 10th term, we can denote this with a sub 10, or this will be read as 10th term. If we have 25th term, we can denote this as a sub 25, or will be read as 25th term. If we are given with 57th term, we can denote this with a sub 57, or will be read as 57th term. Okay. When given the general term of a sequence, he can find the other terms. Okay, example number 1. Find the 10th term of the sequence given the term n term is equal to 5n minus 1. So take note, we will be looking for the 10th term, and we are only given with this general term. The n term is equal to 5n minus 1. So how to solve for it? Okay, let's have solution. Again, we will use the formula given or the nth term given, that is n term is equal to 5n minus 1. Take note, we will be looking for the 10th term. So therefore, we will substitute n by 10. So n here will become 10, and this n here will also be replaced with 10. That's the second step. Next step, copy still a sub 10. So we have simplify 5 times 10. So this will become 50. Copy minus 1. Next step, 10th term is equal to 50 minus 1, and that is 49. So therefore, our 10th term is equal to 49. So how did we come up with 49? We will simply substitute n with 10 because we are looking for the 10th term. After that, simplify. So we come up with 49 as our 10th term. Next is, we have example number 2. Find the 15th term of the sequence. Given the general term, we have n term is equal to 2n minus 1 over n. Or n term is equal to 2 times n minus 1 over n. Take note, we will be looking for the 15th term. So solution here, so we will use the given general term. Next, we will be looking for the 15th term. So our n will be replaced with 15. So n now will become 15. This n here will become 15, and this n here will be replaced with 15. So substitute n by 15 because we are looking for the 15th term. That's why we are using 15 here. Next, a sub 15 or the 15th term is equal to 30. How did we get 30? That is 2 times 15 is equal to 30. Copy minus 1 over 15. Next is, the 15th term therefore is 449 over 15. How did we come up with this? That is 3 minus 1 over 15. That's 449 over 15. Or simply cross multiply. This 30 here has a denominator 1. So this will be 15 times 30. It's 450. Minus 1, because this 1 times 1, that's 1. So minus 1 is 449 over, multiply the denominators. We have here denominator 1 and we have here 15. 1 times 15, that's 15. So our denominator here is 15. So therefore, our 15th term is 449 over 15. As simple as that. How did we get it? Again, substitute n by 15. Then simplify. So we come up with that 15th term. Another example. Example number 3, find the 8th term of the sequence. With general term, n term is equal to n plus 1 over n. Solution. We have our general term, that's a sub n, or n term, is equal to n plus 1 over n. So we are going to look for the 8th term. So we will substitute n with 8. N here will become 8. This n here will be replaced with 8. And this n here will also be replaced with 8. We are using 8 because we are looking for the 8th term. After substituting, so we will simplify. 8 term is equal to 65 over 8. How did we get 65 over 8? So that is 8 plus 1 8. Or simply, 8 has a denominator 1. Then cross multiply. 8 times 8, that's 64. That 1 times 1 here, that's 1. So 64 plus 1, that is 65. 1 times 8, that is 8. We have the denominator 1 here. Times 8, that's 8. So we have 65 over 8. Again, that's 8 times 8 plus 1. That's 8 times 8 is 64. Plus 1, it's 65 over denominator 8. So our 8th term is 65 over 8. Example number 4. Find the 1000th term of the sequence whose general term is given by n term is equal to negative 1 raised to the power of n plus 1. 1000th term, take note. So solution, we have, using our general term, this one, substitute n by 1000 since we are looking for the 1000th term. So n will be replaced with 1000. This another n here will be replaced with 1000. After substitution or after substituting n with 1000, we will evaluate or simplify. 1000 plus 1, that's 1001. And negative 1 raised to the power of 1001, that is negative 1. So our 1000th term is equal to negative 1. Okay, that's it. Thank you. And this is Teacher Con.